We'll go ahead and start with our speaker. This session is on climate change, a topic, of course, of great interest and substantial academy involvement going back many decades. Our speaker is Spencer Weart. Spencer is Director Emeritus of the Center for History of Physics at the American Institute of Physics up in College Park. Originally trained as a physicist, he is a noted historian specializing in a history of modern physics and geophysics, and his books include Nuclear Fear, A History of Images, a great book on the nuclear age, and also, most pertinent for our purposes here, The Discovery of Global Warming on the History of Climate Change Research. And I should add that those of you who go pick up that book are only scratching the surface, because there's a lot of stuff that Spencer could not include, but is helpfully posted on a website. So I will turn it over to Spencer.
Well, last year the National Academy of Sciences issued 10 publications on climate change. There was a report on sea level change, a national strategy for advancing climate modeling, there was a set of booklets for the public, and so forth. All that based on scientific predictions that are still about things going a century ahead. I really can't think of any issue like this that has ever provoked so much attention and concern. So what role did the Academy play in raising these concerns? Were the Academy's actions at a given point in time appropriate? Were they effective? These are the questions I am addressing today. Now, the first collective statement on global warming, and I'm going to be contrasting the Academy statements with those that are issued by other people. The first collective statement by a group of scientists came in 1963, and it was not from the Academy. The impetus was David Keeling's demonstration that the level of carbon dioxide in the atmosphere was rising dramatically year after year. And that prompted the Private Conservation Foundation to convene a meeting. The meeting set the pattern for many later ones. There were a few experts in carbon dioxide and climate, along with a handful of experts in forestry, agriculture, and so forth. And it resulted in a consensus report. The report warned that if fossil fuel burning continued, the Earth will be changed, more than likely for the worse. They could scarcely say what would happen in the next century. The only thing they felt confident about was that there would be a rise in sea level, bringing immense flooding to low-lying areas. Their primary recommendation was that more research was needed, more money should be spent on research. And meanwhile, they called on the National Academy of Sciences to create a committee to look into the whole subject of climate change. But the next step was not taken by the Academy. They didn't heed the call. The next step was taken by the President's Science Advisory Committee, which had formed a pollution panel to address issues such as smog. It included, however, a sub-panel to discuss the efforts of the effects of carbon dioxide. And they reported that there could be marked changes in climate. With remarkable foresight, they predicted that such changes might be apparent by the year 2000. This was back in 1965. Without attempting to say anything specific about impacts, they remarked dryly that the changes could be deleterious from the point of view of human beings. Meanwhile, another form of climate change had become a national issue, namely deliberate modification through artificial rainmaking or other interventions. In 1966, and now the Academy finally steps in, the Academy answered a government request to report on climate modification. And the report of the panel on weather and climate modification included as a minor side issue the question of inadvertent climate modification, that is to say, warming from greenhouse gas emissions. The Academy panel sedately warned against what they called dire predictions of drastic climate changes. They remarked that the geological record showed swings of temperature, and although some of the natural climatic changes have had locally catastrophic effects, they did not stop the steady evolution of civilization. However, they did believe that carbon dioxide buildup should be watched closely, and their primary conclusion was a recommendation that is featured in almost every report ever issued by the Academy. We might call it the Academy's motto, something that could be inscribed on the front of the building. More money should be spent on research. Now, concern grew among the few scientists who paid attention to climate theories. A landmark study on man's impact on the global environment was conducted at MIT in 1970, and among other impacts, the group suggested that greenhouse warming might bring widespread droughts, changes to the ocean level, and so forth. Meanwhile, the international community, so here's the study of man's impact on the global environment. Meanwhile, the international community launched a global atmospheric research program, GARP. That was partly in response to greenhouse warming concerns, but was mainly to improve weather prediction and other near-term issues. To manage American participation in GARP, the Academy set up a U.S. committee for the Global Atmospheric Research Program, which included many top scientists. But I don't have time today to discuss what the kind of thing the Academy did in coordinating international scientific research. Other people are talking on that, and I'm just going to talk about the influence on national policy. In 1975, the Academy's GARP committee published an influential report. It was a bit more alarming than previous Academy statements. They declared that we simply cannot afford to be unprepared for either a natural or a man-made climatic catastrophe. The panel agreed that there was a significant likelihood of a major deterioration of global climate in the years ahead. But they could not say just what sort of a deterioration. Global warming was only one possibility. About the only thing the scientists fully agreed on was that more money should be spent on research. Back in 1960, the Academy had established a geophysics review board that was dealing with international research in the field and coordinating the Academy's activities. In the early 1970s, the board took up the idea of a decadal survey of geophysics. We've heard a bit about decadal surveys. It was a decadal survey of geophysics. The board sets out, in fact, a set of surveys in various areas, growing to 24 reports in all, given the fragmented nature of the geophysical community. And one of the reports would be on energy and climate. This panel of experts announced in 1977 that average temperatures might climb as much as 6 degrees Celsius by the middle of the 21st century. And unlike previous panels, they got rather specific about the potential impacts. On the positive side, the Arctic Ocean might eventually be open to shipping. On the negative side, marine ecosystems might be seriously disrupted. Stresses on the polar ice caps might lead to a surge of ice into the sea, bringing a rise in the sea level of about 4 meters within 300 years. As for agriculture, there could be benefits, but also terrible disasters like the recent African droughts. The panel concluded vaguely that world society could probably adjust itself, given sufficient time and a sufficient degree of international cooperation, but over shorter times the effects might be adverse, perhaps even catastrophic. The Academy's experts were by no means prepared to recommend actual changes in the nation's energy policies. They only suggested that it might eventually turn out that the world would need to reduce the use of fossil fuels. Their main recommendation was, of course, to spend more money on research. The panel otherwise avoided concrete advice, but they did drive home a general truth. The threat of climate change was intimately connected with energy production. As a page 1 headline in the New York Times summed it up, scientists fear heavy use of coal may bring adverse shift in climate. Now, the Academy's call for more research and for better organized research, too, did not fall on deaf ears. The meteorological community and its friends in the federal bureaucracy were determined to push for a consolidation of climate research. In 1977, the Academy created a climate research board with, unusually, a full-time chair, Robert White. The board coordinated the Academy's climate work and provided a channel for advice to the government. It took the lead in promoting a consolidated federal research program, and to skip over a whole thicket of politics, indeed Congress passed the National Climate Act in 1978 and established a National Climate Program Office. The next significant report came from the Jasons. In a 1979 study, they looked into the chances for climate change of any kind, global warming or otherwise. They concluded the world's food supply could shrink, the sea levels could rise. In either case, there could be a displacement of populations, a national security problem, refugees. The president's science advisor, geophysicist Frank Press, now asked the Academy for a report. In particular, he wanted a second opinion on what the Jasons had identified as the most crucial issue, namely, how valid were computer models of climate? A summer study was duly organized, convening for a week in Woods Hole in July 1979. The panel was chaired by veteran computer modeler Jewel Charney. Charney's group found that the different computer models were all indeed in the same ballpark for the temperature in an atmosphere with twice as much carbon dioxide. That's the level we expect to reach later this century. To make their conclusion more concrete, the Charney panel announced a specific range of numbers. They had rather high confidence that it would be 3 degrees, give or take 50%. This has stood up remarkably well over the years. The latest IPCC report still gives you 3 degrees as the most probable value, give or take a degree or two. The panel also remarked that absorption of heat by the oceans would delay a noticeable rise of heat in the atmosphere by decades. It takes longer for the effects to show than just raising the carbon dioxide level. It takes a couple of decades before that shows up in the atmosphere. A wait-and-see policy, they declared, may mean waiting until it is too late. Now, this quiet conclusion was not entirely remote from politics. In the wake of the oil supply crisis that had struck in 1979, the nation was considering a massive program to produce synthetic liquid fuels from coal, that is, synfuels. Some scientists warned that this would lead to a massive outpouring of carbon dioxide, and they used greenhouse warming as an argument against the synfuels program. One incident I'll mention now is just one small example of the sort of work that the Academy did outside the formal structure of reports and so forth, out of public view. On July 18, 1979, even as the Charney panel was gathering in Woods Hole, the Academy's president, Phil Handler, got a call from Senator Abraham Ribicoff. The senator was co-sponsoring a bill on synfuels, and he wanted to know the implications of greenhouse warming. Handler went to the National Research Council's Climate Research Board, and the very next day they provided a statement on carbon dioxide and energy policy. The statement confirmed that global warming could be a problem. They told Senator Ribicoff the massive expenditures required to create a national synthetic fuels capability should not commit our nation to large-scale dependence on coal for the indefinite future. I think this is the first time that an Academy group issued a specific policy recommendation, ambiguous though it may be, related to global warming. Eventually, Congress passed the 1980 Energy Security Act. It did set up a synfuels program, but it also provided for renewable energy sources. And by the way, it appropriated funds for a more substantial Academy study of greenhouse warming and its policy implications. This one would engage scientists by the dozen. In 1983, the Academy issued the full fruit of this effort, a 496-page report, Changing Climate. The scientists agreed that they were deeply concerned, and they pointed out that we may get into trouble in ways that we had barely imagined. For example, if global warming released methane, a potent greenhouse gas from seabed sediments. These cautions, however, were only passing remarks within a summary that was on balance reassuring. The committee chair, William Nierenberg, and some of the economists involved in the policy advice sections were skeptical of warnings of future disaster. They saw environmental regulation as a danger to free markets, and they believed that America's technological prowess and adaptability would surmount any problems. Projecting a mere degree or two of climate change, of temperature change in the foreseeable future, Nierenberg's summary of the report said that climate change is far from novel. Large numbers of people live in all climatic zones and move easily between them. At worst, people who found themselves in the wrong place could move, as people had often done in the past. Heading off any threat of government policy making, the panel's chief recommendation was that the only thing to do at present was, yes, to spend more money on research. Now, Americans might have received and ignored this, but 3 days before, the Environmental Protection Agency had released its own report about the greenhouse effect. The science was mostly the same, but the tone of the Academy's conclusions was more anxious. Substantial increases in global warming may occur sooner than most of us would like to believe, with catastrophic possible consequences. The report insisted that work on new energy policies should get underway without delay. The result was a caustic public debate. The controversy alerted a sizable fraction of citizens to the prediction that stood at the center of both reports. It was official. There was a real risk of future global warming. As Time magazine put it, at the very least, the inhabitants of the planet must begin looking more seriously into how they might live in a new, hotter world. Not necessarily prevent it, but at least how to adapt to it. More money was in fact spent on research, spurred especially by American scientists acting through the National Academy. Starting in 1983, various organizations came together to develop an international geosphere-biosphere program. Again, the work that the Academy did to organize this program is something I could give another long talk about. The international community was taking other steps to address global warming. Most significant was a conference that gathered scientists from 29 nations at Villach, Austria in 1985. They found that global warming would be faster and more serious than Nierenberg's group had predicted. Pointing out that the rate and degree of future warming could be profoundly affected by governmental policies, the Villach report called on governments to consider positive actions. Indeed, the conference's report gave direct policy advice calling on governments to consider a global convention to prevent too much global warming. Plans advanced and a world conference did convene some 300 scientists and others in Toronto in 1988. For the first time, a group of prestigious scientists called on the world's governments to set strict specific targets for reducing greenhouse gas emissions, namely to reduce carbon dioxide emissions by 20% of 1988 levels by the year 2005 as an initial global goal. Very ambitious. They said immediate action was needed. It helped that this conference was held during the summer of 1988, when exceptional heat and drought in the United States caused much public worry about climate change. Congress, concerned by the public uproar, called on the Academy to conduct a new study. The charge was to establish the scientific consensus on the rate and magnitude of climate change, estimate the projected impacts, and evaluate policy options for mitigating and responding to such changes. The academies undertook a massive effort, and this wasn't just the National Academy of Sciences, it included the National Academy of Engineering, the Institute of Medicine, and I'm lumping all these things in National Research Council when I talk about academy efforts. The scientists involved ranged from so-called alarmists like Stephen Schneider to so-called deniers like Richard Lindzen. The panel finally produced a 944-page report, Policy Implications of Greenhouse Warming. It was published in 1992, but the public seen the main results in April of 1991. A common first impression was captured by the headline in the New York Times, "Panel says nation has ability to adapt to global warming." The Associated Press story found the panel optimistic about the ability of American industry and farming to adapt to the climate change, and quoted from the report, "Human adaptability is shown by people working in both Riyadh and Barrow. Recent American migration has on average been toward warmth." In an unusual step, the Academy published a dissent by one of its members, the policy expert Jessica Matthews. Disruptions would be worse than the panel predicted, she insisted, and she remarked tartly, "The fact that one can move with ease from Vermont to Miami has nothing to say about the consequences of Vermont acquiring Miami's climate." Now, looking a little closer into the report, reporters recognized that the panel was far from advocating the wait-and-see reports that had dominated the previous major one, the one chaired by Nierenberg. It would be best to undertake mitigation with international cooperation as insurance, for by the panel's reckoning, insurance is cheap. The panel considered restricting emissions directly through taxes and regulations, but they judged that in general, incentive-type measures are preferable. The government should impose national energy-efficient building codes, should strengthen support of mass transit, should use incentives to increase automobile gasoline mileage, and so forth. Overall, they felt that emissions could be cut between 10 and 40% below the 1990 level at low cost and at some net savings. As Time magazine put it, though both sides could find some support for their positions in the study, its findings and recommendations could prod the go-slow faction in the White House, George Bush's White House. The report brushed aside claims, many emanating from the White House, that reducing greenhouse emissions would be wildly expensive and a blow to economic growth. Overall, the report provided a comprehensive and sophisticated menu of options for both mitigation and adaptation. If a good fraction of the recommendations had been implemented, the nation would be in a much stronger environmental and moral position today. Unfortunately, the report got scant attention from the White House or from Congress. Now, that was the last comprehensive Academy global warming study for a long time, for work had risen to the international level. Starting in 1988, the Intergovernmental Panel on Climate Change began a process leading to massive reports that far exceeded international political clout, anything that the Academy could have attempted. That did not leave the Academy without a role. There remained many kinds of specialized studies relating to global warming that it was in a good position to undertake. For example, the study on the implications of sea level rise that I mentioned earlier. Meanwhile, a minority of scientists were speaking out against the IPCC's gradually coalescing consensus. The technical criticism that was most widely noted came in brief reports issued between 1989 and 1992 by the conservative George C. Marshall Institute. The anonymously authored pamphlets came with the endorsement of Frederick Seitz, a former head of the Academy. The most prominent of the skeptics' claims was that if warming had in fact been observed since the 1980s, if warming had in fact been observed in the 20th century, it could all be explained by an increase in solar activity. In 1990, the National Research Council's Board on Global Change decided on its own initiative to look into the question, and in 1994 they issued a report that was unequivocal in rejecting the skeptical claims. The skeptics now turned to measurements by satellites that monitored the Earth. According to an analysis by one group, there had been no rise of temperature at middle levels of the atmosphere, but instead a slight cooling. It was as if this one set of observations could disprove that the planet was warming. In an attempt to settle the controversy, the National Research Council again appointed a panel to conduct a full-scale review. The panel concluded that something was fishy. Perhaps some temporary influence was keeping the mid-levels of the atmosphere from showing that warming was bound to happen. All they could really say was that more research was needed, but certainly global warming was not disproven. And the panel's hunch was confirmed in 2004 when meticulous analysis of the satellite data showed that, in fact, the analysis had been incorrect. And in fact, there had been warming in the middle levels. One final example involved the hockey stick controversy. As a graphic demonstration of the recent human influence on climate, Michael Mann and colleagues' curve showing a sudden research rise of temperature and unparalleled impact. And the minority of people who were denying climate change came up with many objections to the curve's validity. In 2005, Representative Joe Barton, chair of the House Energy and Commerce Committee, launched an investigation that promised to give the deniers a platform. The new president of the Academy, our own Ralph Cicerone, wrote to Barton to oppose a congressional investigation. Better, he said Cicerone, to ask the Academy to undertake a study. But it was a defender of science, Representative Sherwood Boehlert, who now asked the Academy to review all the evidence of surface temperature measurements. Again, a panel was duly formed, and again they found that the hockey stick was basically valid, and this again has been borne out by many subsequent studies. On a larger scale, the George W. Bush administration wanted to reject the conclusions that the IPCC was reaching. As Time.com reported, the skeptics in the administration suspected that while they were out of power, a left-wing conspiracy had sought to take control of energy policy by whipping up a panic based on false science. They clearly believed that asking these questions to their own scientists would disprove the claims of those calling for action on global warming. And so they went to the National Academy of Sciences with questions framed to give them the answers that they wanted to hear. The Academy had less than a month to respond to the questions. Diverging from the usual slow process of soliciting funds from government agencies, the Academy supported the study out of its own resources. The result was exactly the opposite of what the White House wanted to hear. The committee reported that the IPCC's conclusion accurately reflects the current thinking of the scientific community on this issue. Now, I'll end my story with a set of reports that Congress commissioned from the National Research Council in 2008 and were issued in 2010. Four-volume America's Climate Choices, the Academy's most comprehensive survey on the issue to date. With more forcefulness than ever, the reports insisted that future climate change was a severe problem that required an immediate policy response. The Academy issued unprecedentedly specific and urgent demands for legislation to address both mitigation of climate change and adaptation to the changes that are already inevitable. The report, however, had no effect on the legislation that was before Congress. In 2009, the House of Representatives had managed to pass a bill that would institute a cap-and-trade scheme. The Academy report was publicized in May 2010, and in July, the bill died in the Senate, where the Republican minority exercised a veto through threats of filibuster. So, what does this history of half a century of activity tell us about the Academy's choices and its influence? In the 1960s, the first important initiatives were taken by the groups that were outside the Academy, but from the 1970s on, Academy panels and committees repeatedly and correctly took the lead in stating that there was a possibility of harmful impacts, which would show up around the start of the 21st century and get worse thereafter. As you would expect from panels comprised of leaders in climate science, their judgments reflected the state of confidence in the community as a whole. The conclusions ranged from uncertain worries in the 1960s and early 1970s to precise warnings in the 1990s and thereafter. From the Charney Report of 1979 on, the Academy's report said it was virtually certain that global warming was on the way. This was in the face of denial from a minority of scientists, and on several occasions, the Academy confronted deniers and refuted their claims with statements that history has shown to be correct. In policy-related areas, the record is more spotty. Into the 1990s, Academy reports were ambiguous or even optimistic on the question of how severe the impacts of future global warming might be. Impacts research was then in its infancy, and this was a judgment call, but it's worth noting that international conference reports tended to issue stronger reports, stronger warnings than the Academy's panels did. Likewise, it's hindsight to say that the Academy's panel should have called an earlier date for strong policies. Instead, until the 1990s, the Academy only called for more money, advising a wait-and-see policy. This, too, was backward compared to the calls for action issued by international conferences of climate scientists. Still, in retrospect, I would think if the Academy had issued earlier calls for policy, they would have been futile. In terms of effectiveness, the calls for better organization and for more money for research were, in fact, partly successful. But only partly. There was never as much money as the gravity of the problem called for. And in terms of organization, of course, the Academy did a wide range of important work that I'm not covering in this talk. The specific calls for policies to mitigate greenhouse emissions that the Academy issued from the 1990s on met with limited success. The press did take note of the reports. Some recommended measures were enacted, such as restrictions on automobile gas mileage and support for renewable energy research. But in the debates and political warfare surrounding such measures, the Academy's voice was only one in a cacophony of shouts. Indeed, all scientific bodies together were only one group among the bloggers and news media, the environmentalists and industry organizations, the politicians, and the many others who had much to say about global warming. Overall, it is clear that the Academy tried hard, devoting repeated and arduous efforts, but it was exerting its weight on an issue where much larger social and economic forces come to bear. And there's more stuff if you want it. Thank you.
Our next speaker, I feel this is superfluous, but I will introduce him anyway. Ralph Cicerone, of course, is president of the National Academy of Sciences, chair of the National Research Council. His research has focused for years on atmospheric chemistry, the radiative forcing of climate change due to trace gases, the sources of atmospheric methane, nitrous oxide and methyl halide gases, and this has involved him in shaping science and environmental policy nationally and internationally.
Thanks, Peter. Oh, that takes away. I have to get rid of that slide till I need it. Well, bear with it. Let me say a word for my main point today is I'm going to talk about the differences between the world response to the threats to the ozone layer by chlorofluorocarbons with the eventual policy success of the Montreal Protocol and what has not happened with climate change. But before doing that, I do want to mention one of the reports that Spencer Weart just mentioned, the 2001 report that we did in less than 4 weeks for the White House and the new President, George W. Bush. It had, I won't argue with Spencer's characterization of whether or not they wanted to hear it, but I will describe how it was different from a lot of our other reports. I was not here then, I was in California. We did do it in about 4 weeks, and it took full advantage of email. We did have one meeting in person, but groups would write, and then overnight with recognition of time zones, the next group would take over, and the next time you saw it, it had been iterated twice. The project was undertaken by a direct request from the White House, and they sent it over here in the form of 13 questions that had to be answered. So the scope of the project, we decided very early on, after the Academy officers decided that yes, we should respond, we said we would respond just to the questions and stay out of everything else. There was no time to get external funding, so the Academy somehow paid for it itself. And as a small irony, one of the study members on our group was Inez Fung, who was the last graduate student of Jules Charney from the 1979 report. The only person in common to those two reports, I believe, was Bob Dickinson, who had been a very young climate scientist in 1978 or 9, and he was, of course, older in 2001. Well, let me now get back to the main theme. First of all, what happened with the whole view of ozone depletion? The big kick was in 1974, when a theory came forward that some chemicals that were already in widespread use worldwide, chlorofluorocarbons, could survive the upward journey into the ozone layer in the stratosphere, where they would be broken apart by mechanisms much more powerful than they ever encountered at the surface of the Earth, and release chlorine atoms, which then in turn, and this was also a new idea, could attack ozone catalytically, each chlorine atom destroying about 100,000 ozone atom molecules before the catalyst had to be renewed, essentially. And that this was also at a time when the existence of the ozone layer, although it had been proven years before, many years before, people really didn't know if it was static or whether it was being renewed quantitatively and destroyed by anything in nature. And that after the discovery of the DNA molecule and typical structures of typical proteins, it was determined from lab measurements that ultraviolet light can decompose human DNA, such as in skin, all DNA made of similar proteins at wavelengths just short of 300 nanometers are pretty effective. So the connection had been made, and also with epidemiological work of statistical connections between exposure to ultraviolet light and skin cancer, at least in light-skinned people. And of course, the types of skin cancer had already been explored and which were lethal and which weren't. So there was enormous public interest. The chemical products I mentioned had started out to be ideal refrigerants, and they enabled air conditioning to go to places like Florida and Washington, D.C., enormous boom in the production and sales of those compounds. But they got overtaken by aerosol spray products. So by 1974-75, the world was using most of the CFCs in spray cans of catnip, hairspray, underarm deodorant, and many other products. A multi-billion-dollar-a-year industry, mostly in the United States. There was an active group of scientific journalists in those days, which doesn't exist much anymore. And there were immediately congressional hearings convened, and there's some wonderful stories how those happened. But after a number of those hearings in the House and Senate, and there weren't many people involved in the science, so a few of us got invited again and again and again to state and federal hearings. And we began to meet some of the staff people, and they told us that the volume of mail that Congress received on this chlorofluorocarbon ozone problem exceeded anything they had ever experienced before, except for the Vietnam War. So the public interest was large. However, it wasn't clear, and there were demands for regulation of these products. After all, if there was a threat to the entire global environment, a physical part of the environment, not just a nicety or an aesthetic value, but to something that would involve human health and biological productivity, something should be done. Okay, well, the Congress didn't know what to do, and President Gerald Ford, who was in office for a couple of years, put together a federal task force. And their first job was to find out where in the federal government jurisdiction would be. And they concluded rather glumly after a few weeks that only 2% of the aerosol spray products being sold with CFCs as the propellant were under the jurisdiction of any federal agency, the FDA, the Consumer Product Safety Commission, and EPA. So no one kind of knew what to do. They turned to the Academy. And there were many hearings and popular statements that Congress would not do anything until the Academy had analyzed the situation. So the Academy formed two groups, one a subgroup of the other, to look at the reality of the phenomena, what was known about the physics and chemistry of the atmosphere, and a little bit on the biology, and to make a pronouncement. Is this science solid or not? Are the numbers about right? And how big will the impacts be? And kind of as usual, the project took longer than normal. It was scheduled to be released in the spring of 1976, came out to be the fall of '76, but it was for good reason. Some new chemistry had been proposed, in fact, by Molina and Rowland, who had been the leaders in the first proposal, showing that things might be more complicated. Some ancient German literature showed some indirect evidence of another intermediate chemical that could be involved, and it took this more research that may sound comical, but it happened to be necessary to do the research to figure out again. So the Academy delayed its reports until the fall of '76. And this slide shows the reaction of the headline stories in the New York Times and Washington Post on the same day, responding to the same report. And those of you who can read it will see that the meaning is rather different. The writers of the report wrote skillfully and with a great deal of qualification. And essentially they said that, well, a couple of more years of research could determine if regulations and the severity of those regulations could be optimized, kind of thing. But it was, this is the misspelling here. The authors, the reference I got this out of was Lydia Dotto's book with Harold Schiff. It's not Dacco. So let's look back. So federal regulations did follow within a couple of years on the production, sales, and usage of these compounds. State actions had already proceeded. Consumers had made up their minds. Sales of these products went down. Then in 1985, the ozone hole was discovered over Antarctica. Totally unpredicted. This was an experimental observation, had nothing to do with theory. It was not explained by the original theory. And I think the public got very concerned at that point. I remember giving a lecture myself at, I think it was UCLA, with 500 or 600 people. And the crowd turned angry at the end of my lecture. Why didn't you scientists see this coming? How could you have missed this continent-wide disappearance of the ozone layer? So the public was very involved. Let me now mention, and then the Montreal Protocol took effect in 1987. It's been updated several times since. Substitute chemicals have been discovered and put into widespread usage. It's mostly a success story. The Montreal Protocol was revisited several times and made tighter each time because the evidence continued to indicate the reality of this effect. What's the difference now with the climate situation? Let me just offer a few observations. Well, both of them certainly concern the physical, planetary-wide global environment, but there are real differences. In the case of the CFCs, the public had already judged that the aerosol spray products were not essential. There were substitutes to deliver these chemicals. In the case of CO2, and Spencer Weart has already shown the strong connection between human energy consumption and fossil fuels and carbon dioxide, it's pretty pervasive. It's hard to escape the need for transportation, heating, electricity, and lighting. In the case of the chlorofluorocarbons, there were only 6 producers in the world, 6 chemical companies. So the public could blame it on them. You evil producers of those chemicals that we don't really need, well, except for refrigeration. In the case of fossil fuel usage, it's hard to avoid seeing yourself in the mirror as one of the people who's consuming the products that lead to the CO2 release. Climate is inherently more complex than understanding ozone in the stratosphere. For one thing, the biota are involved in climate change in a fairly direct way, whereas the biota are only affected by ozone loss. The ozone situation with CFCs was framed as a science issue. There were discoveries being announced, like the ozone hole was this major discovery that no one had anticipated or could even explain at the time. And it did turn out to be completely due to CFCs and a few bromine compounds. This is shown directly by laboratory quality measurements made on aircraft. In the case of climate change, because so many people are interested in the policy dimensions and what's needed and how difficult and how expensive it might be as opposed to how beneficial it might be, it isn't framed largely as a science issue. The people who are fighting about the reality of climate change, if you read to the second sentence of what they're saying, it's all about policy, very little about science. There are, of course, other dimensions, and Naomi Oreskes has written widely about these other forces at play, such as some industries who, and I mean that in a general term, generic term, people and industries who are trying to undercut the science. And Spencer Weart has given a couple of examples about objections that arose. And of course, one of them was resolved by the further research, the temperature discrepancy between satellites and thermometers. So that's really all I want to say. I do get asked by a lot of people, and I think you do too, of how could we be so successful in protecting the ozone layer from further damage, and how can we be lacking even the low-hanging fruit responses to climate change and fossil fuels. Thank you.
Our next speaker is Peter Gleick, a member of the National Academy of Sciences. He is the first environmental scientist to successfully link general circulation models with regional hydrologic models to characterize regional impacts of climate change on water. He's president and co-founder of the Pacific Institute in Oakland, which is an independent NGO in the fields of water and economic and environmental justice and sustainability.
Thank you, Peter. Good afternoon, everyone. And thank you, Ralph, for that good introduction to some of the things that I'd like to talk about. I'm going to actually start with three observations, personal observations, and then I'll move on from there. The first is that I think we need good science in order to make good public policy. That's the first. The second is I don't think you can make good public policy with bad science. And that gets a little bit to this question of the debate about climate denial and so on. And the third one is there's no guarantee that even with good science we're going to get good public policy. And Ralph's description of the difference between our experience with the ozone issue and the climate issue is a perfect one. And I'm going to talk about some of those in my brief comments. For those of you who were not here last night, Professor Kevlis gave a very interesting talk about the first 100 years of the Academy, the academies, and some of the philosophical underpinnings of what the academies have tried to do over the years, some of the kinds of topics the academies have addressed. And Spencer, of course, has just given a great summary of, in the climate context, what the academy's role has been, the different studies that have been done, going back a remarkably long time. And if there's anything that we should get from Spencer's historical overview, is first of all how remarkable and consistent the Academy's work has been in this area, and long-term it's been. And I think the academies deserve enormous credit for tackling the climate change issue early and often, even in the midst of a difficult, as we all know, political climate around the policy side of things. I'm not a historian, I'm a climate scientist and a hydrologist by training. What I'd like to do is offer some thoughts about the next steps. I'm not going to look back, I'm going to try and look forward about where the academies might go, about how to keep the academies relevant, and maybe how to communicate some of the issues that the Academy evaluates and reports on and then tries to inject to some degree into the policy process. We live in a world with a lot of different competing voices in the science world. And again, Professor Kevlis talked about this a little bit yesterday. It's not just the national academies and the Institute of Medicine, it's industry science groups. And I work for a nonprofit independent research group, and there are university research groups, and there are government agencies that have research groups, and everybody is putting out science and information of varying qualities on varying topics of varying relevance for public policy. And so it's a challenge increasingly in this world to get your message across, perhaps in the way some of us might like. So what are the strengths of the academies in that context? Well, first of all, nonpartisan research. The Academy was set up explicitly to do nonpartisan research. It's not, people don't understand this, I'm sure everyone in this room does or watching on the live stream, that the Academies is not a government agency, it's independent of the government. And the ability of the academies to do nonpartisan research has always been and remains a major strength. Another strength is the ability to do interdisciplinary research. Again, my institute was set up to do interdisciplinary research. It's not an easy thing to do. Universities are not great at interdisciplinary research. The academies have disciplines and sections, and that's a challenge as well. But the committee structures of the academies really permits expertise from a wide variety of areas to be brought to bear on any number of the kinds of problems that the academy addresses. And again, that's not the sort of thing that you get, for example, from science societies. I'm a member of the AGU, there's the American Physical Society, there's the American Chemical Society, there are professional societies in all of the sciences, but it's more difficult for them to do some of the interdisciplinary research that I think is necessary for many of the challenges that face us today, like climate change, and that's something the academies can, and I would argue, and will argue, ought to be doing. Another strength of the Academy is the ability to reach out to the public with public communications, and I'll come back to that one at the end in a little more detail. And then finally is independence. The Academy can't be shuttered like the Office of Technology Assessment was. The Office of Technology Assessment was a research arm for Congress. It was set up, it became politicized, or there were perceptions that it was politicized, and it was shut down. And that science advice is no longer directly available to Congress the way it was. And there are other mechanisms now that provide science advice and information to Congress when Congress is so inclined to listen to it, but the Academy has that independence. And the goal, I would argue, of everything the Academy does is evidence-based policy, of informing good public policy with science. So what does this mean for climate change and the future? Well, first of all, there's lots more science that can be done and will need to be done about the science of climate change, about the role of greenhouse gases, about radiative transfers, about sensitivity of the atmosphere to greenhouse gases. There's plenty of science that remains to be done, and the Academy has and will continue to play a role in that area. In particular, I'll just throw this out. The latest IPCC science report has just been released. The Working Group 1 report has just come out. And there is discussion about maybe it's time for the IPCC to change its structure a little bit, to maybe work a little more quickly. They release reports every 6 or 7 years, and that's a challenge. The reports that they released are not exactly based on the latest science because there's a cutoff date, so the last year or so of science isn't even reflected in the most recent IPCC reports. So maybe there's a role for the academies in the science area in helping the IPCC move to another level or replacing some aspects of the IPCC. That I think is worth some discussion. But the other thing I think is important for the Academy is to look at the science of the impacts of climate change and how to adapt to climate change. I think the argument is shifting, and actually probably should have shifted a decade ago, if the policy community was there, from the science of climate change to what are we going to do about now unavoidable impacts of climate change. Again, the Academy has done work in this area. If you go back and look at all of the climate reports that the Academy has done, a number of them address some of the consequences of sea level rise, the consequences of rising temperatures or increasing frequency of extreme events. So there is some work that the Academy has done on impacts. There's been a little bit of work, less on adaptation, but these are areas where a lot more science needs to be done and a lot more information needs to be both gathered and analyzed and then communicated. How can we adapt? The role of technologies, the role of economics, the role of policy and planning. These are some of the examples of the interdisciplinary nature of these challenges. And this isn't new. The Academy has done this with the impacts of nuclear war, with the nuclear winter debate, including looking at the medical implications of nuclear war in 85 and 86. And Ralph has talked about the ozone issue. There have been reports from the academies on the health impacts of ozone depletion. So the Academy has lots of experience with impacts and cross-disciplinary analysis in these kinds of areas. On communications, I think we need more effort on communications. The climate issue is a highly politicized, polarized issue, as we all know, and Naomi has written about this and may talk about this a little bit, and Ralph mentioned it as well. It's a tough issue for climate scientists to deal with on the policy side, and lots of climate scientists don't want to, and those that do are entering an era with many challenges. I'll leave it at that. We also, though, live in a world where the communications methods are changing, and the internet is a totally new way to communicate. So, for example, I get most of my information from Twitter, or from blog posts, or from news feeds that are pushed to me. I don't wait for a paper version of a climate report from the National Academy. And I think it's time to encourage the Academy maybe to explore even more aggressively than it's done some of these new medium of communications. And I did a little experiment yesterday. This is not a scientific experiment, I'm bad at social media experiments, but I tweeted 3 tweets yesterday, one after another. All 3 of them had a link embedded in the tweet to America's Climate Choices, the most recent, the big climate report from the academies that Spencer talked about and that Ralph mentioned as well. One of them said, cats, 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 climate change, cats, cats, and then the link. The second one said, sex, sex, climate change, sex, cats, and then the link. And the third one said, America's Climate Choices, and then the link. Okay, it wasn't a scientific experiment, I realize, but, and my interest was how many times are these going to be retweeted, that is, somebody's going to pass them on? Is there a way to measure how often any one of those tweets led to somebody actually clicking the link and looking at America's Climate Choices, the report on the website? I can't really give you the answer, except that, in fact, I had more retweets of the America's Climate Choices and the link than the other 2. So I think that's good news. It may simply reflect that the people who choose to follow me on Twitter are more interested in climate than they are in cats or sex. I'm not sure. It wasn't scientific, I admit that. But there are ways of reaching new audiences, and I think we should figure out how to explore them so that the science that we produce reaches a bigger community. Let me wrap up and simply say, don't underestimate the value of having the National Academy state something. It's incredible, even if the policy community ignores it for a while or for a long time. It's incredibly valuable to say the National Academy of Sciences thinks the science of climate change is strong. And furthermore, every national academy of every country on the planet thinks that. And some of the joint statements issued by the US National Academy and the other national academies have been very effective as a way to talk about the strength of the science. So the ability to say those sorts of things has value, even if the policy community is not in the short run listening. Thank you very much.
Thank you, Peter. Very interesting study you conducted there, so there's hope after all, maybe. Our next speaker is Naomi Oreskes, a professor of the history of science and affiliated professor of earth and planetary sciences at Harvard. Naomi's research focuses on the earth and environmental sciences with a particular interest in understanding scientific consensus and dissent. Her 2004 essay, The Scientific Consensus on Climate Change, has been widely cited in the United States and abroad, including in the Academy Award-winning film, An Inconvenient Truth. So Naomi.
Well, thanks very much. It's an honor and a privilege to be here today. And I want to reiterate something that Peter just said. The Academy reports are incredibly important because even if they sit on shelves collecting dust, people like me can cite them. And I've given over 150 public lectures in the last 3 years. And one of the most useful things I can say to what I would call a reasonable skeptic, an educated or informed skeptic who hasn't completely closed their mind, is to say, well, the US National Academy of Sciences said, or even the academies of the world. And actually the piece of my own work that I'm most proud of is not An Inconvenient Truth, although that was important and fun, but it's the fact that my work was cited by the Royal Society in its facts and fictions about climate change. And I was on the fact side. So what I'd like to do now is actually return to one of the themes that Spencer raised in his talk, something that I think is a major issue in the history of climate science, and arguably a major issue for the National Academy of Sciences more broadly, and that is the boundary between science and policy. And in particular, the question, who are the appropriate experts to evaluate a complex issue such as climate change that is simultaneously an issue of science and technology, but also an issue of politics, economics, ethics, and values? As we all know, we heard last night, the National Academy of Sciences is a private, nonprofit society of distinguished scholars, established by an act of Congress and signed by President Abraham Lincoln in 1863. The Academy is charged with providing independent, objective advice to the nation on matters related to science and technology. But this raises the question, who are the relevant experts to give policy advice? And especially, who are the relevant experts when the issues involved are not simply questions of science and technology, but involve aspects of economics, cultural disruption, and social change. In recent decades, as we've already heard, the Academy has addressed numerous issues like climate change, which are not just matters of science and technology, but also matter of economics, politics, justice, and social good. And to address the social, political, and economic aspects of these problems requires expertise beyond the natural scientific disciplines of physics, chemistry, biology, and geology that comprised most of the membership of the early days of the Academy. Indeed, arguably, as we heard last night, most of the first 100 years. The Academy, of course, to some extent acknowledges this by the inclusion of social scientists, particularly economists, in its ranks, in its division of social and behavioral sciences, which we again heard about yesterday, and many others who serve on NRC panels. But despite this growing recognition that Spencer tracks of climate change as a social and policy problem, the panels that addressed the issues were dominated by physical scientists. So let's go back for a minute to that 1983 report, Changing Climate, that Spencer mentioned, that was chaired by physicist and oceanographer William Nierenberg, and which I have, in fact, done quite a bit of detailed research about, including research here in the archives. And that research was supported also by Matthew Schindel, who's here somewhere, so I want to make sure that I acknowledge his contribution. Now, one of the interesting aspects of that report, indeed one of the problematic aspects of this report, and it's not just this report, we see this in other Academy reports as well, was the executive summary. And the gap between what the executive summary said and what the 400 pages of the rest of the report says. As Spencer noted, the executive summary was largely reassuring, suggesting that the problem of climate change, if it even was a problem, was far off in the future, and that we could adapt to any changes that would ensue, and that environmental demands for regulation now were, quote, a danger to free markets. Now, these positions were, of course, potentially reasonable ones and potentially supported by evidence. But who actually wrote this executive summary? And were these claims supported by evidence in the body of the report? And were they supported by the expertise of the panel? The answer to the first question we know from research in the Academy archives is that the summary was not actually written by the panel, but by NRC staffer Jesse Alzabel, but in consultation with Dr. Nierenberg. There was little, if any, input from the other panelists, and we know as well from the archives that some of the panelists were unhappy with the executive summary with that reassuring tone. The entire report was severely criticized in the internal review process by peer reviewer Alvin Weinberg, the head of the Oak Ridge National Laboratory, who argued that not only that the executive summary did not accurately represent the contents of the report, but also that many of the claims in it were not supported by evidence. Now again, whether Weinberg's critique was right or wrong is beyond the scope of our conversation here today. But what I'd like to call attention to is whether the panel had the appropriate expertise to make claims of that sort. That is to say, I would suggest that there was a significant gap between the expertise of the committee and the claims, the reassuring claims made by the executive summary. The key claim was this one of adaptation, that people could and would adapt easily to climate change without undue hardship. From Nierenberg's personal papers and other writings, it's clear that he was particularly moved by the argument that humans had a long history of adapting to climate change in the past, and he argued that there was no reason to think that they would not continue to do so in the future. He did allow that some climatic effects, including sea level rise, which particularly worried panelist Roger Revelle, might drown major cities and make some coastal areas uninhabitable, but he thought that could be addressed by outmigration. He wrote, and I quote, "Not only have people moved, but they have taken with them their horses, dogs, children, technologies, crops, livestock, and hobbies. It is extraordinary how adaptable people can be." Yet the report itself, despite the 400 pages, referred to no historical, sociological, or anthropological studies on the character or effect of known past migrations. The panel included no historians, sociologists, or anthropologists, or archaeologists who might have been able to speak to the relevant evidence. Indeed, in an earlier report to the Academy on the same subject by economist Thomas Schelling, completed 3 years earlier, in 1980, Schelling had noted that past migrations might not be a reasonable analog to the sort of migrations that climate change could trigger because, he wrote, quote, "Today's political barriers hamper migration, and national boundaries are not likely to be more open in the future." Schelling might have also added that past migrations had been associated with large cultural, social, economic, linguistic, and demographic losses, and that many of those horses, dogs, and children had died. Yet nowhere was this point addressed in the 1983 report. Yet, as Spencer notes, the report was widely cited in the mass media to suggest that climate change was not a very serious problem. And it was also used by the Reagan administration to counter the EPA report that came out at the same time, which suggested that it was. Now, a second example, again, that Spencer notes is the 1992 report on policy implications of greenhouse warming, which also focused considerable attention on adaptability. Given its title, a specific focus on policy implications rather than the scientific basis, one might have expected heavy representation on this panel from academic experts who could speak to adaptation, perhaps demographers, sociologists, historians, anthropologists, maybe even psychologists or psychotherapists. But a quick review of the panel membership reveals one archaeologist, Robert McCormick Adams, at that time head of the Smithsonian Institution, and that's it. One professional with expertise on human culture and adaptation in a panel of 14. Or put it quantitatively, 7% of the panel expertise. Several of the panelists had strong political credentials and even distinguished political careers, like the chairman, Daniel J. Evans, former governor of the state of Washington, and Morris Strong, the one-time head of the United Nations Environment Program and an architect of the 1992 Rio Earth Summit. But even these men, Evans' educational background was in engineering. Strong was a businessman turned environmentalist who had started his career in the Alberta oil and gas fields. As Spencer notes, a strong dissent to the committee's relatively optimistic loss was given by Jessica Tuckman Matthews, daughter of the famous historian Barbara Tuckman, and at the time vice president of the World Resources Institute. She explicitly took issue with the way the panel framed the question of climate change as a problem of physical change without expressing the social and cultural meaning of that change. Again, to quote, it's such a great line that I'll quote it again, Tuckman noted, quote, "The fact that one can move with ease from Vermont to Miami has nothing to say about the consequences of Vermont acquiring Miami's climate. Not to mention that you're mixing states with cities, but that's a different issue." Now, Tuckman might also have added that many people, perhaps most, cannot actually move from Vermont to Miami, or at least not with ease. And having myself lived for several years across the river from Vermont in northern New Hampshire, I would say that very few Vermonters could move with ease to any place, much less Florida. The larger point is that moving is not easy. Moving is always associated with social costs, and often economic ones as well. Some things, such as infrastructure, cannot be moved without very substantial economic costs, and other things, such as cultural heritage, cannot be moved at all, or at least not without significant changes in their cultural and social meaning. My last example is the 4-volume report, America's Climate Change, issued in 2010, which again explicitly addressed the policy dimensions of climate change. Again, as a report explicitly dedicated to the idea of choice, America's Climate Choices, it might have been expected to include representation from experts who know something about choice, about how people make them, how we often make the wrong ones from a rational perspective, and what the consequences of our choices are likely to be. Yet once again, we find a panel heavily dominated by natural scientists, starting with the 2 co-chairs, an engineer and an atmospheric science. Perhaps reflecting the obviously and explicitly political character of the topic, as well as the considerable economic dimensions, the panel included a former governor, a former member of the U.S. House of Representatives, a former CEO of the DuPont Corporation, a professor of law, an environmental activist specializing in environmental justice, and this is really weird, and maybe Ralph can explain it, a PR man affiliated with the firm of Hill & Knowlton, famous, or in my view, infamous for its work on behalf of the tobacco industry. The panel also included an economist, a business school professor, 3 geographers, and a professor of sociology. So somewhat unusually for an academy panel, physical scientists were not in the clear majority. Yet many of the policy-oriented scholars, including several of the geographers, had their scholarly training in the physical sciences or engineering, and the professor of sociology held a PhD in ecology. Now, my point here is not to say that the members of these panels were not highly distinguished people. Clearly, they were. Nor is it to suggest that the reports would necessarily have been better or more useful, politically or socially, had they included more experts from the social sciences broadly construed. Yet, given Spencer's observation that the track records of these panels looks extremely robust when one looks at the assessment of climate change as a scientific matter, in particular the quantitative estimates, for example, of climate sensitivity, but rather less robust when one looks at their assessment of climate change as a problem requiring a solution or solutions. Given this difference, a rather solid track record on the physical scientific side, a somewhat weaker scientific record on the social scientific side, one cannot help but consider the character of the expertise that was brought to bear. Again, to sum up, all of these panels, even those explicitly addressing the policy dimensions, were heavily populated by physical scientists and engineers. Many of the people representing policy studies or environmental studies had moved into those areas from the physical sciences. Now, the dominance of natural science, and what we see then as a result, not surprisingly, is that in areas where the panels had strong expertise, they did very well, but in areas where they had less strong expertise, not surprisingly, they did less well. Now, the dominance of natural scientists in Academy panels is, of course, understandable given the history of the Academy, founded as it was by a group of natural scientists based largely in Cambridge, Massachusetts, and including such luminaries of earth science, such as Louis Agassiz, Alexander Dallas Bache, James Dwight Dana, Asa Gray, Arnold Guyot, James Hall, Edward Hitchcock, Benjamin Silliman, and the Rogers brothers. In later years, the Academy came to be dominated by physicists and chemists. The list of Academy presidents is indeed a who's who of physics and chemistry in the 20th century, although some important biologists are present as well, but no social scientists, and one might note, at least so far, no women. Moreover, despite the fact that we call them social sciences and that many contemporary scientific methods and statistics were first developed in the social sciences, many natural scientists still have trouble accepting the social sciences as equally valid as the natural ones. The fact that so many members of these panels who held policy positions in academia and think tanks had their original training in science and engineering perhaps reflects as well a cultural bias in the years since World War II in favor of science and engineering training and in favor of political reliance on experts whose knowledge base was presumed to be apolitical. But as much research has shown, the presumption that physical scientific expertise can be made apolitical is at best arguable. Our own recent work on scientific assessment shows how much scientists, even physical scientists, struggle to create, define, and maintain a clear boundary between science and policy, between findings and recommendations, and between science and society. Thank you.
Okay, thank you, Naomi. So we will have some time for the panel to respond to each other and to Spencer. There are quite a few tidbits to chew on, I think, here. Perhaps starting with Naomi's point about the role, perhaps, of the social sciences and how they might be incorporated into the debate over climate change.
Glad to start. I think it's kind of a universal finding we've had here the last few years, and probably people before me, that we need more social sciences expertise in our studies. So we're on the lookout. All fields of science are highly specialized, so the choices become, how many people can we have on one panel, and what do we expect of that man or that woman on the panel? So we're looking to do these balances, and I accept Naomi's criticism. Once you get into the policy aspects, we ought to have some expertise who are familiar. I will point out, though, that in the case of the chair of the America's Climate Choices overall project, it happened to be Al Carnesale, who, yes, he took his college degree in nuclear engineering, but he was one of the major contributors to United States arms control policy for 30, 35 years, and was a professor at the Kennedy School of Government for I don't know how many years after he made that switch. So we look for people, I think, largely who Naomi just kind of broad brushed as people who have some background in, say, the physical or biological sciences, but who later become real experts in policy matters, like Carnesale was a good example. But we have to do better, we know that.
I think if I could just say one other thing, I mean, and as I obviously said, none of this is intended to disparage in any way, shape, or form the individuals. But I think it is an interesting point that if somebody moves into policy from physics or chemistry or engineering, they may become an expert in many aspects of policy, but nevertheless their worldview, their orientation, the way they think through problems will likely be different than someone who comes, out of psychology or anthropology. And I think that's an important distinction.
What about this issue that Peter raised about communication? Because it's something that was actually kind of striking if you look back at this record of the Academy's engagement with this issue. And going back 30, 40 years now, they've been making these very accurate predictions about, okay, these are the scientific conclusions about climate change, and whether this has become less of a scientific problem and more a problem in communicating those results to the public, and what the Academy can do to shift the focus more from the science, the problem of, doing another study, another report, to maybe doing a better job of just communicating what has already been studied about it. And I don't know if there's, specific examples or suggestions of ways you can, or procedures that are underway maybe to undertake that. Or whether Peter can follow up with some ideas, if you have ideas of your own, on what might be done.
Well, I have lots of ideas, but this is a little bit of a touchy subject because not all scientists like to communicate. Not all scientists are good at communicating. And then there's a question about the form and the forum for communicating. So I think the academies should be tweeting more. I mean, that sounds silly, and many of you probably are not on Twitter, but I've become very fond of it. And look, Jay-Z and what's her name, Miley Cyrus, they have millions of followers, and the Academy has a couple of thousand. I looked up today. A couple of thousand isn't very good in this world, but the Academy could be a bigger voice in that area. But does the Academy want to? The Academy doesn't write op-eds per se. Individuals write op-eds, but is there a way for the Academy in a more public way, rather than just these scientific reports that most members of the public don't see, unless a journalist writes about them, to put out shorter, more readable pieces of information about stuff that the Academy has done, about science that's already been published by the Academy, but perhaps needs to be digested a little more in a different form. There are lots of options, but I don't have the answer because it partly depends on what the Academy sees how the Academy sees its role.
One model might be I think it was in the 80s, they started doing these white papers on science and creationism, science and research ethics in the context of the Baltimore case and whatnot, and whether the Academy has thought about or is doing anything maybe along those lines, or take that model but apply it to maybe new media.
Actually, can I give you two quick examples? Just a couple of weeks ago, it was revealed or discovered or announced that the Los Angeles Times is no longer going to be publishing letters from climate deniers. And there was a little bit of a brouhaha. Some people said, oh, it's censorship. And the editor wrote the letters editor wrote a very nice piece in the LA Times saying why. And he said, look, we simply we have a responsibility not to publish errors of fact. That was pretty straightforward. I don't know if other newspapers are going to follow suit with that sort of thing. I don't know whether the academies would have a policy about editorials or letters to the editor, that kind of thing. But the other example came up last night. One of the winners of the Communications Prize was the USA Today for their story on somebody remind me. The lead pollution, incredible example. But this week, the USA Today, I don't know how many of you know this, has a long-standing policy of they publish an editorial and then they always have a counterpoint written by somebody. The editorials are editorials, they're not named, written by somebody who opposes the editorial. They published an editorial this week about the science of climate change and the IPCC and how clear it was and how the scientific community is even more sure that humans are influencing the climate. And then they published an op-ed, I won't say by whom, opposing that point of view, which was not by a scientist, but by a climate denier. And so I asked the guy last night at the reception, the editor, I pigeonholed the editor, and said, okay, so if somebody had written an editorial saying the Earth is round, would you have felt compelled to have a countervailing argument from a member of the Flat Earth Society? Because I believe that the science of climate change is that good, almost that good. Anyway, so.
What did he say?
Not my department. I put him on the spot, it wasn't fair. But it's a legitimate question that I think is a question about this science and communications issue.
Yeah, I think, you're right. I agree with everything you said. It's touchy, though, and it's delicate because obviously there's a wide range of opinion within the academy and the scientific community on some of these issues. But I think your point, Peter, is a really important one, that there are models, even within the academy's own history, of ways in which the academy can be a measured voice in a really, really helpful way. And I think the stuff on evolution is a really good model. I was thinking about one of the things that's in my inbox this morning is the recent decision of the British Medical Journal not to publish scientific articles funded by the tobacco industry. And my email erupted because this is something that a lot of people in the scientific community are not sure what to think about. And one thing that was interesting to me to see in the email that I got is how many scientists really do not understand what the tobacco industry did to biomedical research in this country over the last 50 or 60 years. So there were a lot of people saying, oh, but we have to support debate, we have to, it's not right for a journal to censor. But there are facts about this matter, and there are facts about tobacco that are different than some other debates. And I think that that's the kind of place, maybe that would be an Institute of Medicine. Are we here like the whole academy or just the academies? I don't know, I'm confused by that, but all three. Okay, so if we're here for all three, that's good. Okay, so, there are some very specific facts about the tobacco industry, which include the fact that they were convicted of fraud under the RICO statutes, and that a significant part of that fraud, as founded by the US Department of Justice, was the use of scientific research, or we could say the abuse of scientific research by deliberately funding projects that were not aimed at finding out the truth about the harms of tobacco, but were aimed at undermining the scientific evidence. And that is such a betrayal, of what science is supposed to be in scientific research, that it seems to me that's the kind of thing that the academy, the Institutes of Medicine, could say, here is why this is significant, here's why this decision makes sense. And it doesn't mean that you're saying that all corporate sponsorship of scientific research is wrong.
Let me address this issue of communications just briefly. On the materials tables outside, there's this brochure, The Science of Science Communications. We've now held 2 rather large meetings about this very subject, about what are people doing, what's the evidence base for what works, what are the goals, and who are the best practitioners. And it's a tough subject, but it's extremely important, as Peter just said. Richard Garwin said something this morning about something for which he deserves a great deal of credit, and that is getting all of our reports distributed free on the web in PDF form all around the world immediately to other countries in the world especially. This is trying to communicate, disseminate more widely, but in addition, we've developed short summaries, oftentimes written by communicators rather than scientists, of the contents of these reports. On climate change, we have something going now with the Royal Society in London, where a group of our scientists and their scientists are getting together, writing a peer-reviewed, very short document on the reality of climate change. What is the evidence? What are the frequently asked questions, to speak to the general public. Generally, though, we have to be cautious and conservative It's better when we're asked on a subject. History shows that the impact of our reports tends to be larger when we're responding to questions that we were asked rather than offering opinions. Then how do we separate evidence-based conclusions, findings, and recommendations from those which have less evidence and are more personally or value-based? We try very hard to do that in our reports, and that's where a lot of the qualifiers come in. We are playing around with YouTube, and there's probably somebody twittering from this room right now, and we don't make any attempt to stop them, but we are tweeting. Why this sudden attention to vernacular as opposed to good English when that's the last thing you find in tweets? But anyhow, there are people experimenting with disseminating our reports with Twitter feeds as well as YouTube. But most importantly, we have to get it right. If we stand for anything, it's coming up with the most objective, most reliable analysis of any topic we can. And that will always be, as far as I know, the driving force here.
Well, in the time remaining, why don't we open it up to questions from the audience, because we like to give people the chance to respond to the panel. We have a gentleman on this side.
Yes, Joe Whitty from George Mason. Peter, I saw your sex tweet, and I wasn't quite sure what to do yesterday with it. And Naomi's right. Having been in the physical science and now switched to the social sciences, the culture of people plays such a huge role in the whole thing. And I applaud Ralph and the past two Sackler communication sessions that we had. In AAAS magazine, what was it, 2 weeks ago, has a cover story about science communication. So it's a very important topic. I would posit that, and I saw that story about the LA Times, that is a real milestone, I think. And I would posit that if the National Academy can't or doesn't or perhaps ought not to write editorials, then perhaps the Academy, the AMS, the AAAS, the geological societies can urge their members to just flood the Wall Street Journal editors, just flood the Forbes magazine article as individual scientists, and perhaps then we'll get to the point that the LA Times editorial board is at, hopefully.
Thank you. Gentleman over here.
My name is Peter Wallenus. I've been a member of the Academy for more than 20 years. And I found this a very interesting, and served on many NRC panels. And I found this a very interesting presentation because, you know, we've been hearing that one of the attitudes of the Academy and of scientists has been to be apolitical. But very often when you're on one of these panels, these questions that might have a political tinge get in there. For example, the question of a conclusion being always, from every NRC report, you know, more money is needed for research. That has been used, obviously, by people in climate deniers as a negative. It's been said that, you know, the report clearly only said they need more money, and so that's what they're interested in. So what would be your advice to scientists on NRC panels? Should we scrupulously avoid saying that, or say it only when it's something that's really, truly a burning need? Likewise, if people have their political opinions about whether people can move from place to place, I would say this historical review says we should not probably have said anything about that because we weren't expert enough. Should we be very, very rigorous about removing such things from statements and limit ourselves to making statements that can be put in numbers? What are your feelings?
Well, of course, more money is needed for research. We're very underfunded, especially nowadays. I think that it's most effective when they refer to specific places, as many of the reports do, but probably this should be propagated into the summaries that more money is needed because the monitoring, for example, is insufficient to answer such and such questions, or in some cases the Academy reports have pointed to a lack of organization in the research and have advocated sometimes quite effectively for changes in the way that the research was organized. So by all means, the Academy should in any form of advertising, repetition is important. And we certainly shouldn't let the fact that deniers point out that we make, that our livelihood is dependent on this, dissuade us from pointing out as often as we can that research is badly underfunded in the United States.
I would just add quickly, I think it's a specious argument. More money is needed for research. There are lots of uncertainties. There's lots more science that we need to know. Lots of reports say that, but I don't know any scientific report that only says that. The Academy reports say, here's what we know about the science, here's what we don't know, here's what we'd like to know, and more money might be useful for that. But the argument that we're simply saying more money is needed for research, I think, is an incorrect and specious one. And anyone who thinks we're in this for the money isn't in this business. I'll just leave it at that.
Yeah, I agree with that completely, but I want to add one other thing just about the political dimensions of problems. I mean, it's clear that the political dimensions of problems don't go away by pretending they're not there. And I think we have a lot of research and philosophical work on the question of objectivity, and I think it's pretty clear that objectivity doesn't mean that you don't have views, but it does mean that you're open to evidence and you're willing to consider alternative views in the face of evidence, and that you go and look for the evidence that is relevant to the claim. So when I was doing the research on that 1983 report, I asked an important person in the Academy, who I'll leave unnamed, how did this get through peer review, and why weren't the peer reviewers' complaints taken more seriously? And this person said, well, the Academy peer review process wasn't as rigorous in those days. So the good news is it's more rigorous now. But in hindsight, it seems to me pretty obvious that if you have a panel, and I think this does happen with some panels, if you have a panel that is coming to the conclusion that the most significant impact of climate change is going to be that people will be forced to be dislocated because of sea level rise or other climatic changes, well, you could then say we need to do a follow-up study, or we need to bring in some experts on dislocation migration, some demographers, right? And I think that does happen more now than it did 20 years ago. But I think that's one of the ways that you would deal with these things. You say, well, what are these implications? And if we don't have the relevant expertise, then let's go get that expertise.
Okay, our time is almost up. I mean, we have a queue at the microphone, so we'll try to get through as many as we can. And I think next is on this side.
Yes, I'm Türkan Gardner from Pragmatica Corporation. My husband, who is also in the audience, and I have had long-term careers as statisticians within the government and within the health field. Now, we were alarmed a couple of weeks ago in a meeting where patient recognition of science was discussed and how diversely interpreted were percentages. For example, in dealing with dose, if you take 50% of the dose, how much would you be taking? And they'd say half. What about 70%? Oh, that's about half. What about 35%? That's about half. So there was, let alone integral science and differential equations, a survey of what terms are interpreted by the public would be quite useful in terms of simplifying material for communicating results to people who use statistical terms in conveying information.
Okay,
Do you have any feedback on that?
Well, we got the red light. Are we allowed to take one more question? Yes. Okay, we'll take one more question over here.
Eugenie Scott, National Center for Science Education. I think there's a useful maybe rule of thumb for looking at things like the Los Angeles Times refusal to publish climate denier arguments. There's a difference between what is understood through science and what is an opinion about science or something that you should do about science. It's not a matter of opinion whether the Earth goes around the sun or the sun goes around the Earth. It would be silly to have point-counterpoint op-eds or allow a series of letters to the editor about whether or not geocentrism or heliocentrism is a better model of the solar system. There may be implications of heliocentrism, so fine, have opinion pieces about should we worship Apollo or should we not worship Apollo. Those are opinions. It's not a matter of opinion whether the planet is getting warmer. It is a matter of opinion what you should do about it. And that is where we should encourage the balance. We should encourage newspapers to talk about the implications of climate change or the implications of evolution. But living things have common ancestors. The planet is getting warmer. People have a lot to do with it.
So Jeannie, that's a great point. The editorial and the counterpoint in the USA Today piece was on the science of climate change. And I mentioned to the editor, I said, look, it would have been great to have an editorial about the policies around how to deal with climate change and a counterpoint, because there's a huge debate to be had in that area. I agree completely.
Can I just make a brief statement? Not a question?
Very brief.
Very brief. I just worry about people who decide to publish one thing and not publish another. Suppose the Washington Times, for all I know it does it already, decides that it's not going to publish anything about abortion, about evolution, only about, what's the other one called again?
Creationism.
Creationism. We'd be up in arms screaming, okay? It's dangerous to let newspapers decide what the public should see and what they shouldn't see. I happen to think that, you know, the Times is probably right in spirit, but maybe not as a newspaper.
Okay, I have to respond to that just briefly, because I agree in principle, but the fact is that that is what the Washington Times does, and it's what the Wall Street Journal does. And talk to Ben Santer about this. The idea of flooding the Wall Street Journal with letters is a great one in principle, but we know that even when extremely distinguished scientists write letters to the Wall Street Journal, even when they're very fact-based and lay out in very clear detail why the editorial was incorrect factually, the Wall Street Journal does not publish the letter, or worse, they publish it, but they edit it in a way that makes it seem as if it said something different than it did. So it's a really, really difficult problem, but I think given the political realities, I agree with Peter. I think the Los Angeles Times has done the right thing.
I just recommend you read the rationale written by the editor of the letters editor in the Times. It's really nicely written.
I encourage us to continue this discussion out in the Great Hall over some coffee, and I thank our panel.